Hello, my name is Emily, and I will be going over our next lesson, which will cover partial fraction decomposition. Let's get started. So first things first, what is partial fraction decomposition? A fancy definition could be the manipulation of fractions by combining and separating factorable terms. Basically, all we're going to do is use what you know about factoring to simplify fractions. And this could be to separate out fractions into two different terms, combining fractions. It just depends on how you need to simplify the problem and what will help you the most when you're solving. So let's practice. And for this video, we're going to do an in-depth example with the following problem. So it says, in the numerator, 5x minus 4, all divided by x squared minus x minus 2. So the first question we're going to ask ourselves here is, what can be factored? So please take a moment, pause if you need to, and look at our terms here. Which of these can be factored? All right, now you've had a good look. I hope you noticed it's the denominator. Our x squared minus x minus 2, dead giveaway. So we can break that into the classic x plus 1 times something. We know 1 times negative 2 will give us negative 2, and then negative 2x plus 1x is going to give us that negative x. So we have a negative positive factor going on there. So now that we've established what is our factored term, the next question we're going to ask ourselves is, how can we separate this single term into two? In our case, we're going to try and separate out our terms. And the same process can be repeated backwards if you need to. But let's try and separate this out. This is also kind of the trickier question. But hopefully you guys can think of common denominator. So what's going on here? Let's break it down. So we went from a single term, and then we've broken apart into two. And we leave the numerators here as kind of just general fake terms. So we're just going to call it A1 belonging to the x minus 2 term, and A2 belonging to the x plus 1 in the denominator term here for now. But what do I mean by common denominator reversal? Well, think about it. In regular, 5th grade math, we learned, all right, if I have little q divided by capital Q plus little r divided by capital R, I'm allowed to combine these if I get myself a common denominator. And I can achieve that by multiplying each term by 1, or in this case, capital R divided by little r, capital Q divided by little q. And then we know that'll get us in the end, little q times capital R plus little r times capital Q. And we know that common denominator is capital Q times capital R. And look, we have this same format here. We're going from the final common denominator term, and we're looking for these terms on the far right. A1 divided by capital Q, A2 divided by capital R. So how are we going to solve this problem? If you look, we have the format right here. Maybe take a moment and pause and think about how these numerators are going to change when we're solving. So what we're going to do is simplify it like this. So we have the final term, the 5x minus 4 term here on the left, and we know on the right, the A1 will get multiplied by the x plus 1 term. It's because it's multiplied by a common denominator. Same, the A2 will get multiplied by the x minus 2 term, because that's not what's currently in its denominator. So this will be what we're trying to solve. We're solving for two variables, A1 and A2. So how do we solve for these two variables? Systems of equations. So what follows here will just be a basic breakdown, hopefully a review of your systems of equations skills, but here we go. First things first, we're going to multiply those coefficients across. So, first things first, let's multiply the coefficients across. So we end up with a1 times x, and then a1 times positive 1, and we know a2 times x, and then a2 times a negative 2. Now, to make our lives easier, let's put all of the x terms on the left and all the non-x coefficient terms on the right. So what that'll look like is we know we have to subtract the a1 and the a2x terms to be on the left, and we'll just have to add that 4 to be able to place it on the right. So now we have two unknowns, a1 and a2, and we need to solve for the values. So let's use equilibrium and stick both sides equal to 0 in order to make two equations. So we know if we minus everything on the left-hand side, it needs to be equal to everything on the right-hand side. So this minus that will be equal to 0. And for the left-hand side here, you just divide out by 0, it's still equal to 0. So that's how we dropped that x coefficient term here. So next, you have a couple ways to solve for your two variables. I just showed the additive method, meaning I added the two equations together, but I really suggest trying the substitutional method on your own. When you solve for one variable in terms of another, plug it in and solve for it. So just quickly, we know if I add down 4 plus 5 is 9, a1 minus a1 term goes away, negative 2 a2 minus 1 a2 will get me my negative 3 a2, and that's still equal to 0. So we place the 9 on the other side, divide by negative 3, and we think a2 is equal to positive 3. Plugging that into our second equation here, we know 5 minus 3 is positive 2. Place it on the other hand, on the other side, divide by your negative, and our best guess is a1 should be equal to 2. So great, we have our solution, right? Always double check. Let's just be super sure of our answers, and on any quiz, if you have the opportunity, I definitely suggest double checking yourself. So this is what we have in theory. a1 was the numerator to x minus 2, and 3, a2, is the numerator to x plus 1. So let's see what happens. Let's apply common denominator. We're going to multiply 2 divided by x minus 1 times x plus 1, and 3 divided by x plus 1 times x minus 2. So we know common denominator will end up being this term. We're not worried about that. We're more concerned about the numerator. So 5x minus 4, 2x plus 1, 3x minus 2. Multiply our coefficients, 2x plus 2, plus 3x minus 6. And then 2 plus 3 is 5. Positive 2 minus 6, negative 4. True. We are good to go. So in review, let's go all the way up. See all that hard work you guys did? You all did. We went from 5x minus 4 divided by x minus 2 times x plus 1, and we were able to separate it out to be 2 divided by x minus 2 plus 3 times x plus 1. Thank you.